Hey everyone, I'm Evan Lee. Today, I'm pumped to walk you through the ins and outs of designing RESTful APIs, which are pretty much the backbone of any cool app you're using on the web or your phone. In the next 10 minutes, we're going to break down what makes an API not just good but great, focusing on those RESTful vibes that make our APIs smooth, easy to keep up with, and ready to grow. So, let's kick things off by getting a solid grip on what RESTful APIs are all about. REST, short for representational state transfer, is like the golden rule book for crafting web services that don't just work well but also play nice with the rest of the internet. Born in the early internet days, REST takes everything we dig about HTTP and turns it up to 11, allowing different bits of the internet to chat it up seamlessly. When we talk about a RESTful API, we're talking about an API that sticks to REST playbook. This isn't about picking rules at random. It's about choosing guidelines that make sure our services run like a dream, are rock solid in the reliability department, and can handle growth without breaking a sweat. With REST, we get to use straightforward HTTP methods like get to grab data or post to send it, making our API feel familiar and easy to get the hang of. Plus, it means our API can work with just about anything out there on the internet. The real magic of a RESTful API is how it acts like the perfect middleman, grabbing the latest tweets or putting through your order on an e-commerce site without missing a beat. This consistent and standard approach lets us build web services that folks can easily get, use, and hook up with, leading to a web that's more connected and way more efficient. Embracing REST is all about laying down a solid foundation for our web services, ensuring they are not just ready for what users need today but can also adapt to whatever the future throws our way. All right, let's dive into why using those standard HTTP methods is pretty much the cornerstone of making awesome RESTful APIs. It's like discovering the perfect set of tools for the job. Get, post, put, patch, and delete. Each one is chosen for its clear purpose and plays a crucial role in making sure our APIs are easy to get and work with. Kicking off with get. This method is your go-to when you just want to read or pull info from the server. Think of it like flipping through a catalog. You're just looking, not buying or changing anything. It's super important because it ensures that no matter how many times you hit refresh, you're not going to accidentally order a dozen pairs of sneakers unless you really want to. It keeps things safe and predictable, which is gold in web development. Moving on to posts. This is where you get to add your own content to the catalog. It's not just about submitting forms anymore. It's how you tell the server, hey, here's something new. Whether you're signing up for an account, posting a comment, or uploading a pic, post is your method for sending data that creates something new on the server. It's the beginning of interaction, turning users from viewers into contributors. Then there's put, the method that's all about updating. Got a profile update or want to change your order? Put is like saying, let's replace the old with this new info. It's your all or nothing approach. If you're updating a user profile, you're sending the whole profile, not just the bit you're changing. It's about keeping things in sync and ensuring that if something exists, it's exactly as you specify. If not, it gets created. Patches put more noise cousin. Instead of replacing everything, patch says, just tweak this part. It's perfect for those times when you want to update just your profile pic without touching anything else. It's about efficiency and focus, reducing the amount of data shuffled back and forth and honing in on just what needs to change. Finally, delete does exactly what it says on the tin. It removes stuff. When you're done with a resource, whether it's deleting an account, removing a blog post, or canceling an order, delete is how you tell the server to take it out of the catalog. It's crucial for managing data lifecycle, ensuring users can control their content and that apps stay tidy and relevant. These methods form the core language of RESTful APIs, making sure that everyone's speaking the same web dialect. They're about making our interactions on the web as intuitive as possible, mirroring the way we think about actions in the real world, viewing, adding, updating, tweaking, and removing. By sticking to these, we make APIs smarter, more intuitive, and way easier to work with. They're not just about rules. They are about making the web a more coherent, user-friendly place. So, diving into RESTful API design with these methods in your toolkit isn't just about following standards. It's about embracing a philosophy that keeps the web open, interactive, and easy to navigate. It's about building experiences that feel seamless. All right, let's bring it back a bit and talk about naming stuff in APIs and why it actually matters more than you might think. So, when we're setting up our RESTful APIs, how we name things and the URIs we use are super important. It's all about making things clear and easy to guess for anyone jumping into your project. Think about it like naming your playlist so you can find your workout tunes without a hassle. Using nouns for naming is like sticking to the basics, but in the best way possible. If you're doing something for a bookstore, having an endpoint named /books is straightforward. It's where you'd expect to find all the books listed. And when you want to zoom in on one book, /book/ID makes it clear you're looking at one specific book based on its unique ID. This setup is clean, simple, and it just makes sense. This approach isn't just about keeping things tidy. It's super practical. For one, it makes your API a lot easier for developers to get. They won't need to scratch their heads figuring out what things are or how to access them. It's also about planning for the future. With clear and simple naming, adding more stuff down the line gets a lot easier. Plus, when it's time to update or change things, having a clear and consistent naming scheme means less confusion and fewer headaches. But there's also something cool about predictability in your API structure. It kind of gives developers a roadmap of your API without needing to dive deep into docs from the get-go. They can make some educated guesses about where to find things, which speeds up the whole process of working with your API. And let's be real, anything that makes life easier and gets us to our goal faster is a win. So, in a nutshell, spending some time thinking about how you name things and set up your URIs is more than worth it. It's about making your API intuitive to use, easy to scale, and straightforward to maintain. And honestly, making things easier for yourself and everyone else who might use your API is pretty much the goal. After we've nailed down how to name our stuff and what kind of methods we're using to chat with our API, the next big thing is making sure we're speaking clearly when things go right, go wrong, or just need to head in a new direction. That's where HTTP status codes come into play, acting like the emojis of the API world. They give you the quick and dirty on what's actually happening. HTTP status codes are super handy because they give immediate feedback. Think of them as the API's way of saying got it, or whoops, my bad, without needing to dive into the details. When you're dealing with web services, knowing right away if something went smoothly or if you hit a snag is crucial. It's all about keeping the conversation between client and server as transparent as a freshly cleaned window. Let's break it down with a few key players in the status code game. 200 OK is your green light. It means everything's cool. The request went through, and here's the data you asked for. It's the thumbs up you're hoping for with most of your GET requests. Jumping to 201 created. We're in the territory of making new stuff. This code pops up when you post something new, like a comment or an account, and it's the server's way of saying, yep, I got what you sent me. And look, I made something with it. Now, 400 bad requests is where things start getting a bit cloudy. It's the server's way of telling you, sorry, buddy, but you're not making sense. Maybe you forgot to fill out a part of your request, or you're asking for something that just doesn't compute. It's a nudge to go back, check your request, and try again. And then there's the 500 internal server error, which is essentially the server's version of a shrug. It's like it's saying, something broke, but I'm not sure what. It's a flag that something's gone haywire on the server side, and it's not your fault, but it still needs fixing. Using these codes, and there are a bunch more for all sorts of scenarios, effectively means you're keeping everyone in the loop. Developers working with your API can immediately see what's up based on the code, adjust their requests accordingly, or handle errors with grace. It's about making the interaction with your API smooth. But it's not just about handling the moment, it's about planning for the future. By using these codes wisely, you're building a more resilient and user-friendly API. It means that as your API grows and evolves, developers can rely on these consistent signals to guide their integration and debugging efforts. In short, you're not just coding, you're communicating. So, as we move forward, let's remember that these HTTP status codes are more than just numbers. They are an essential part of the dialogue between your API and its users, ensuring clarity, efficiency, and a good developer experience all around. As our API grows and changes, we face the challenge of evolving without messing up the experience for current users. In the versioning, our strategy for keeping things smooth is like having different editions of a book. Some people might still be reading the first edition, while others move on to the newer one. You can put the version number straight in the URL, like /von/books for the original version, or /v12/books for an update. This method is super direct. Everyone can see which version they're using. Or, you might prefer using custom request headers to manage versions, which keeps the URL clean and still lets users choose their version. The bottom line, clear versioning lets everyone know what to expect. It allows users to upgrade on their own schedule, ensuring nobody gets left behind or breaks their app by accident. It's all about making the API's evolution transparent and manageable for everyone involved. As we start getting our API's architecture off the ground, one thing's for sure, we've got to lock it down. Security isn't just a nice to have, it's essential. Rolling out heavy hitters like OAuth 2.0, HTTPS, and making sure we're strict on what inputs we take are key moves. These aren't just about keeping the bad guys out, they are about building trust. Think of it as the digital equivalent of locking your car. Doing the basics can go a long way in making sure everything stays safe and sound. Then there's the whole deal with rate limiting. Picture this, you're at a concert, and there's this one refreshment stand that everyone wants to hit up. If everyone rushed it at the same time, it'd be chaos, long waits, frustrated fans, and a good chance the stand runs out of drinks. That's where rate limiting comes into play. But for your API, by setting up a system where each user has a clear allowance on how many times they can call your API within a certain time frame, we're doing a few crucial things. First off, we're keeping the traffic flow steady and manageable. This means our API can serve up data without breaking a sweat, ensuring that all users get a smooth and responsive experience. No metaphorical crashing of the refreshment stand here. But there's more to it than just keeping the server from getting swamped. Rate limiting is like having a fair ticketing system. It ensures that no single user or application can monopolize the API. This is key in scenarios where you've got limited resources to go around. Just like limited refreshments at the concert, everyone gets their fair share, and the service stays up and running for all. On the flip side, rate limiting also acts as a first line of defense against potential abuse. Think of it as the bouncer who's got an eye out for anyone trying to cut the line or cause trouble. If an overly eager bot or an overzealous developer starts hammering your API too hard, rate limiting steps in to slow them down, protecting your infrastructure from accidental or malicious overload. This is especially crucial in warding off DDoS attacks, where attackers try to flood your API with more requests than it can handle, aiming to knock it offline. Implementing rate limiting can take various forms. You might opt for a simple X request per hour model or get more sophisticated with dynamic limits based on user behavior, time of day, or the type of request being made. The beauty of rate limiting is that it's flexible. You can tailor it to fit the specific needs and patterns of your API usage. In essence, rate limiting isn't just about putting up barriers. It's about ensuring a fair, secure, and stable environment for everyone who uses your API. It's a crucial piece of the puzzle in creating APIs that are not just powerful and useful, but also resilient and equitable. By thoughtfully applying rate limiting, we're not just managing traffic, we're upholding a commitment to quality service and reliability, no matter how crowded the digital concert gets. Now, for the real magic to happen, we need killer documentation and a smooth developer experience. Tools like Swagger or Postman aren't just nice add-ons. They're what bring your API to life for the folks using it. With clear guides and examples, we're not just making it easier to get started, we're building a community. It's about giving developers everything they need to dive in, play around, and maybe even improve on what you built. Before we call it a day, let's hit pause for a second. Think about everything we've gone through. Which part seems like it's going to be the toughest nut to crack in your projects? How's it going to shape the way you approach building your API? Take a moment, jot down your thoughts. This isn't just academic. It's about getting your hands dirty and making things work in the real world. Thanks for taking that moment. Your insights and challenges, they're gold for anyone serious about nailing API design. So, let's keep all that in mind as we wrap this up. Closing out, crafting RESTful APIs is more art than science. It's about mixing the right technical moves, like choosing the right HTTP methods, naming things in a way that makes sense, using those HTTP status codes wisely, versioning smartly, doubling down on security, setting fair usage limits, and rolling out the red carpet with awesome documentation. When we blend all this together, we're not just building APIs, we're creating experiences that developers love to use.